Blair. I'm happy to be here talking with you. And this is about our partnership with the Transitional kindergarten and an early math learning game. And I'm a researcher in the AAALab here in the Graduate School of Education. The lab is headed by Professor Dan Schwartz, who's unfortunately on the other side of the country today, so can't be here. But I'm going to be talking about our project. So recent research has shown that early math skills are a powerful and important predictor of later school achievement. And there's been an increasing focus on math learning in early childhood education. Traditionally, there's been sort of a stronger focus on literacy, and math hasn't gotten quite as much attention, but this is starting to change. And there are some interesting projects going on here at Stanford. And one of the things that's really part of this focus is on helping students develop a flexible understanding of number. So having a strong or flexible number sense involves a lot of different facets. It's more than just knowing the counting sequence. It involves things like cardinality, knowing if you count 3 objects, 3 represents the size of the set and not just the name of the 3rd object you count. Ordinality, knowing that 3 comes after 2. Relative magnitude, 3 is more than 2. So there are a lot of different facets that go into having a robust and flexible early number sets. And we and other theorists sort of think that it's important to integrate these different conceptions of number. And so to this end, we developed a research project that had 3 primary goals. The first was to develop and evaluate a tool to help children construct strong number sense. And so to this end, we made an iPad app called Critter Corral, which focuses on early number concepts and specifically on integrating different ways of thinking about number and different representations of number. And I call it a tool because we see this as not as replacing the entire math curriculum or as ousting hands-on manipulatives. We see this as one resource among many that we want teachers to have that has particular affordances that makes it good at some kinds of things. So for example, it can provide immediate feedback, give students a chance for extended practice, there can be a consistent spatial or visual representation, and it can be adaptive to the learner. So we view this as one tool among many. A second goal of the project, so the one I'll be focusing on the first one mostly today, but a second goal is to learn more about trajectories of early math learning. And one way that we're going to try to do this is we've given students 3 out-of-game math interviews at 3 points during the first semester of the school year. We've done 2 so far. And we're also collecting in-game data as students are playing the math iPad game. We're collecting information about reaction time, accuracy, which games they're playing, what levels, etc. And we're hoping to link these together to get more of a sense of trajectories of learning. And also find a way to report this back to the teachers and to the district in a way that's meaningful and useful for them. And the third goal is to answer questions about feedback and learning in interactive environments for young children. So our survey of the for young children that are out there, it didn't seem like in many of them that a tremendous amount of deep thought and reflection had gone into the ways that they provide students feedback when they get the answer right or when they get it wrong. And so this was something we wanted to investigate further. And so we're doing our research with the Transitional kindergarten, which is an interesting program. So the cutoff date for kindergarten has moved. And so Transitional kindergarten is for students who now just missed the cutoff date for kindergarten. So they all were born, they turned 5 between October and December. And so this is approximately 250 students that we were working with. We got to work with all of the Transitional kindergarten classes, which has been fantastic. They're in 14 classes at 8 sites. And so they're actually part of the K-12 school system, so they have credentialed teachers and about 22 students per class. But they're generally housed physically in the early childhood centers. And one of the things that's really exciting about this is that it covers all of San Francisco. So we're able to work with all of the Transitional kindergarten classes, which means we have a large amount of diversity in the students that we're working with. And so to talk about what we actually did, so this is a screenshot of the Critter Corral game. And the story for the student is that their job is to help take this sort of worn down Wild West town and return it to its former glory by helping each of the businesses in the town. And so they help the businesses by helping them solve problems that they need solved. So each of these icons is one game or one business. And they all have very similar play patterns, but different ways of representing number. And so you'll see these patterns coming up as I talk about each one. They really focus on one-to-one correspondence and equivalence. So I'll show a quick example of each of the games. So the Station Master game. In this game, the student's job is to help the station master figure out how many train cars are needed to fill the train so it can go off and deliver its cargo. So if the student says 4 train cars appear, they count off one by one. There's no volume to do, and then the train's able to move on. In the restaurant game, here the student's job is to help chef figure out how much food he needs to cook for this many customers. So in this level of the game, the student would drag the right number of foods up onto chef's tray and then press the go button. And if they've dragged the right number of foods, then everybody gets a food and they're all happy. The chair game, you can see some patterns emerging here. This is the theater game where they're trying to help fix the chairs so that the characters can all sit and watch a show. Right now the chairs are broken, so they can't watch their show. And so in this case, they have to decide which leg will fix the chair and drag it into place. Sometimes the sizes are continuous, sometimes they're discrete and countable, and sometimes the students' answer choices are just symbolic number. The fourth game, this one, someone has very foolishly left Monkey in charge of the train deliveries. And so the student has to help Monkey figure out how many spaces he needs to go to deliver the present to the character who's waiting. And so in some levels, the spaces are sort of countable. In others, the student has to estimate how many tracks Monkey has to lay out to reach the customer. And then finally, the last game shows how we try to incorporate different physical interactions into the game. And I actually think this is something that we can push on more in future work. But we tried to sort of abstract those physical interactions as students moved up in levels. So in this game, you're trying to tell Crab how many feet the customer has, so he brings out the right number of boots. And in early levels of the game, you count the bug's feet by touching each leg itself, and touch it once and only once. In later levels of the game, we actually touch in this tan box down here to bring out the number of boots to tell Crab how many legs the customer has. So we're sort of taking that from going from touching the actual object, abstracting a little bit, now you have to tap somewhere else. And one of the things that is interesting is we can capture in the data log files when students touch the legs and when they touch the box, so we can kind of see different strategies like touching the leg, touching the box, touching the leg, touching the box, touching the leg, touching the box, versus touching all the legs and counting them and then touching in the box that many times. So we can look at some interesting strategy data there. So that's a very quick synopsis of the game. One last thing I'll say about it is that we made 2 versions that give feedback differently, because we're interested in this question of how should these kinds of games provide feedback. The versions are exactly identical, except for when a student answers incorrectly, and then they do different things. And in our current study, that seems to happen in about 30% of attempts. One version I'll call more traditional feedback. So if the student answers incorrectly, there's a noise indicating that they're incorrect. They can try again. On their 3rd incorrect attempt, they're shown the correct answer and why it's correct. The other feedback version, I call implication feedback, because it shows the implications of what the student chose relative to the target amount. So you can see how far off you are from the target amount and try to fix it. And so we think this might have some benefits for focusing students' attention on the quantitative dimensions of the problem and not just on whether they're right or wrong. So to show a very quick example of what this looks like in the fastest game. So here the students trying to figure out which leg will fix the chair. If they pick this leg,
too short.
Oh, it's too long, he slides back. If they pick the right size leg. And so students sometimes like to get this one wrong on purpose, so they're just solving a different problem. And so we think that, as I said, this might help students focus, and it might highlight the dimension of discrepancy, which might focus student attention on the kinds of quantitative relationships we're interested in. So this is one example of a playback from a student. And this is the restaurant game, and they're trying to tell chef how many customers there are, so he knows how much food to cook. And if you touch a customer, it turns a different color and giggles to help students count. So here, when you see the customer change color, that means the student is touching it. So in this case, this is sort of halfway through the problem, and the student has incorrectly told Chef that he should cook 3 foods. So Chef has 3 foods on his tray. Oh, wait. And so now the customers line up, and it turns out that there are 5 customers. Chef has his 3 foods that he's cooked on the tray, and unfortunately, some customers wind up without food. And so you can see the student's really focused. They're sort of touching those customers without food, and then when they have an opportunity to fix it, they very quickly add more to fix it. So we think that maybe this kind of feedback where it really shows how far off you are, how many, too many, too few, too long, too short, might have some effects over just focusing on correct or incorrect. So our research study design with the transitional kindergartens, as I said, we were able to work with all the transitional kindergarten classes, and everyone has been extremely supportive. We were a little bit worried at first whether there would be teachers who who had issues with having technology in their classroom or were not excited about it, but every teacher has really actually been quite excited to have us working with them, so that's been really great. There are approximately, as I said, 250 students in 14 classes. We had 5 iPads per class while the students were involved in this study, and we left them in the classroom for about 5 weeks. We were there for the first couple of sessions to help the students get used to it, but then after that it was very much teacher implemented. And so the study design, this is actually the first half of the study, and this is where we are right now. We just gave these mid-assessment interviews, so this is what I'll be focusing on. So we gave all the students a pre-assessment interview, which was a 20-minute one-on-one interview where we asked them a bunch of questions. Then cohort A, 7 of the classes, used the app about 3 times a week for 5 weeks. And wherever possible, we tried to split within school so that one class would use the app, one class wouldn't. So cohort B, the other 7 classes, did not use the app. They just went about their regular day. And then we had a mid-assessment, which was the same kind of one-on-one interview with the students. And within the students who were using the app, we randomly assigned students to the different feedback versions. So this part of the study lets us look at sort of pre to post gains for students who are using the app versus students who weren't. Then there's a crossover for the second half of the study that I'm not going to get into today. This is right about where we are, but this lets everybody use the app, so the students who weren't using it now get it in their classrooms, and it lets us address some additional questions. So the measures that we were looking at, first we have the in-game measures. So from the log files we can get accuracy, reaction time, game and level choice, and some student actions like counting. We also have out-of-game measures. So we have these interview assessments. Some of the items were adapted from standardized tests, so count these boxes, for example, name this digit, make a pile of 7. Other measures we developed ourselves to target the skills we think the game is developing. So like in this game over here, the student has this assessment item, they have a little frog character and these lily pads, and they get a card like this, and their job is to make the frog hop that many lily pads, and then also to predict how many more lily pads a frog would have to go to reach the jewel. And then we also had a sort of a control measure, so we had students do upper and lowercase letter naming in the core phonics survey, and so we did not expect differences between the 2 conditions on this measure. We did expect it on the math measures. Just to talk very quickly about the use of Critter Corral so far, we found that we told teachers about how much we wanted them to use it, but we gave them a lot of leeway in how they wanted to use it. So most teachers made it available during choice or station time, and this was generally in addition to their regular math time. Some teachers used it during their regular math time as one of the math activities. And so it'd be interesting to look at differences there. And the teachers reported being mostly hands-off after the first few days when students got the hang of it. So just some very, very preliminary results. So we just finished giving the assessments last week. But some quick looking at the letter assessment. As expected, we didn't find any significant differences for the classes who didn't play the game versus the classes who did. This is sort of pre-post game. But we did find significant differences on the math assessment for students who didn't play the game in gray versus did play the game in gold. And in particular, if you look at the percent of possible gain, So this is sort of how much they can improve before they hit ceiling. We see that the classes who didn't play the game gained about 10% of that, and the classes who did play the game gained about 20%. So that's it's very preliminary, but sort of promising. So our current and ongoing work, obviously, to continue the second half of the study, we're still going, to look more closely at the feedback version differences. This is really interesting to me, to try to link the in-game and out-of-game data. And related to that, figure out how to report the assessment information and also the in-game information to teachers in a useful way. And finally, we had Critter Corral for free on the iTunes store. We pulled it for this study because we had different versions and we didn't want kids playing it at home. But the plan is to take what we learned from this study, improve it, and then put it back on the iTunes store for free download. And I want to thank my Jessica's here, among others, for their help.